that is going to resolve business problems in your company. You should know that companies are faced with business problems all the time, especially when the problem involves uncertainty. Now watch me. I've built a business model that actually take care of when we have three uncertainty: uncertainty in demand, uncertainty in number of price of products sold, and uncertainty in the number of production. Now this is a beautiful business model that you can build for your company to save them money and be able to plan. Now watch this. If I have number of products produced 1,800, I have the demand to be 1,700. Now watch. Number of shares sold at full price 1,007. Number of shares sold at reduced price 100, and the profit is 12,900. Every information changes. Now let me change this again. You can see the model works for all kinds of uncertainty. Now let's say I have 1,700 shares produced and the demand is actually higher, 1,008. Now watch, number of shares produced 1,007, because what? I cannot sell the number of shares more than the number of shares produced, even if the demand is high. And watch the number of shares sold at reduced price, 0. The model work, and look at the profit. It changed from $12,000 to $13,000. I will be doing the very first project on business analysis, and we will be doing that in Excel. Okay, so today I'm going to teach you how to build a business model when you have two uncertainty in your information. Now let's quickly go through the scenario so we can understand it. A t-shirt producer who plans to produce t-shirts for Brazilian football supporters at the next FIFA World Cup tournament. The fixed cost of any production is $800. The variable cost per t-shirt to Ahmed is $8, and Ahmed's selling price is $20. However, the price will be charged only until a week after the tournament. After that time, Ahmed figures that the interest in the t-shirt will be low, so the plans to sell all remaining t-shirts, if any, at $6 each. The best guess is that the demand for the t-shirt during the full price period will be 1,500. He is thinking about producing 1,450 t-shirts, but he wants to build a spreadsheet model that will let him experiment with the uncertainty demand and his order quantity. How should he produce? Build a spreadsheet model for this. Now, every day in every organization, there is always uncertainty. So this is where business analyst comes handy. The business analysts are able to look deep into any business problem and be able to build a business model to solve this problem. So join me, let me take you right into it. Now, first, what I advise business analysts to always do is this. First, you have to take all the given information from the scenario or from the business, then before you start to work out your uncertainties. And most time, uncertainties will be represented by dummy values, means you will make up some values and use them, do some trial and error till you get the particular model that works for all. And when you build this model, you can actually use this model to solve other business problems that have similarities. Okay, so and that is the advantage. You build it once and you can use it forever. Okay, now so let's build this particular business model, and this model can be saved and can actually be used in other business problems that have similarities in uncertainty. All right, now first let's take all the given information. Equals to $800. So we have $800. Then the second information given is variable cost. So the variable cost is, so the variable cost is $8. So this is $8 per t-shirt. Okay, $8 per t-shirt. All right, so this kind of scenario, since he have an overhead fixed cost of $800, he will really want to produce more to be able to cover for this overhead cost, right? All right, now let's check the order given. The order given is a week dollar. So let's start putting the prices. So selling price equals to $20. So this is when you write them out, it makes it easier for you to understand the question properly or the business problem properly. Okay, is then the price he will be charged only until a week after the tournament. After the time, Ahmed figures that the interest in the t-shirt will be low. Yeah, this is true, because definitely after the tournament, a lot of fans will not want to buy the t-shirt any longer. Let's say Brazil lost, or even if Brazil win, they have all bought what they need to buy. So definitely the demand for the t-shirt will be low. So he plans that at low price is going to sell, at low demand is going to sell $6. That is after the competition. So we have two information here. So let's put this selling price at high demand. Okay, selling price high demand $20. So we now have another selling price low demand. So you can see we are dealing with two information here. So selling price at low demand is $6. Okay, $6, right? So we've been able to get all this information out. So now let's go to our Excel worksheet and start to impute them. So let's go to our Excel worksheet and start to on the cost. This Ahmed t-shirt as the header. The cost, fixed cost, we have $800. Variable cost $8. These are given. Now for revenue, we have full price. When we sell at full price, we will be selling $20 per t-shirt. Okay, this $8 per t-shirt. So let me put it there, per t-shirt. Okay, and $20, we are selling at $20 per t-shirt, means one. All right, and now at reduced price, we're giving that at reduced price we sell $6 per t-shirt. Okay, so having known that, we also have this information that the number of shirts produced, let's assume that he will produce 1,450 from the same question, and the demand, he knows the demand is 1,005. So the number of shirts sold at full. Now the first thing we want to know is, we want to confirm the number of shirts we want to produce. Now let's say, for example, they have decided to produce 1,500 t-shirts. Now let's put what we don't know. First, we don't know demand. We don't know how many shirts that will be demanded for, right? We are not too sure of how many shirts. You know, every company goes through this same problem. They produce number of quantity of products, but they are not too sure of demand. But they always have a very close guess, okay? So we don't know demand. So let's put this as green, okay? So I'll go to home, come here, then select green. So it's an unknown, so that's why I'm highlighting it. Then also, we don't know the number of shares sold at full price. You know, we are going to have two variables here. The number of shares sold at full price. Okay, the number of shares sold at full price. Let me extend it. It's past the border. Okay, so the number of shares sold at full price, we don't have this also. We don't have this information. Home, let me also use a color to represent it. So I can use yellow. So I don't know the number of shares sold at full price. And I also don't know the number of shares sold at reduced price. Okay, reduced price. Let me extend this also. All right, so let me use another color, home. Come to this place, then let me use, okay, let me use blue to represent this part. Okay, so let me use blue. All right, now we don't know three things. We don't know the demand, we don't know the number of shares sold at full price, and we don't know the number of shares sold at reduced price. So this is where we are going to do our modeling. So this is where we are going to use logic to get our modeling. Now let's say, for example, if the demand, let's try and form a model that will work. So we are going to use some dummy variables. Okay, so now let's say, for example, if the number of shares produced is 1005 and the demand is 1450, that means the number of shares sold at full price will be 1450, will be this same 1450. So we click here, we hit enter. So this is what the number of shares sold at full price will be. Means that at full price, the whole demand was bought, right? Because this was demanded during the season. And definitely number of shares sold at reduced price will be zero. They will not have a single share to be sold at reduced price. Now, this is good for the company. Now, let's say, for example, if we change the demand to be 1,600, for example. Now, if we have 1,600, the number of shares sold at full price, you can see here we change 1,006. But this is impossible because we cannot have the number of shares sold at full price to be 1,006 when we have produced 1,005. So means that the only total number of shares we can sell here will be changed. Means it's going to be equals to the number of shares produced, which is this. So if you see at these two models, when it was high, when it was low at demand, 1,450, this place is 1,450. But when the number of shares produced is lower than the demand, the number of shares that can be sold is the lower part. So definitely what this means that out of these two, we are going to always pick the mean, the minimum. Because when the demand was 1,450, this place was 1,450. That's the number of shares sold at full price. And when the demand now exceeds the number of shares produced, the number of shares sold at full price picked the lowest, which is number of shares produced. So we have to use a formula that will work for both of them. So what we do is we want to pick equals to mean. We want to pick the minimum of these two at any time. So any one of the minimum of these two. So which means we open parentheses. This is how we build the model. So we are going to click here, B10. Here, but it has to be the minimum. So that's why we are using this mean function. So anytime we have two values here, this mean function will pick the mean of both of them, and that is the only way that mean will represent the number of shares sold at full price. So if I click enter, you can see what did it pick? 1,005, because 1,005 is the minimum here. Now, for example, if I increase this to 1,700, you know what this will pick? It has to pick this demand, which is 1,600, because 1,600 is lower than 1,700. Because even if I produce 1,700 t-shirts, I can only sell at full price what is demanded, and what is demanded here is 1,600. So if I click here, enter, you can see it has changed to 1,600. Means the function, the formula is working here, the model is working here. So I can easily write equals to formula text to bring out this formula. So formula text, open parenthesis, click on this value, close it, and you can see means it's going to pick minimum between number of shares and the demand, because the number of shares sold at full price must always be the minimum of both of them. So that is our first resolved. Now our second resolved, number of shares sold at reduced price. Now let's see, what do we need to have here? Let's say, for example, the number of shares produced is 1007 and the demand is 16, right? Definitely the number of shares sold at reduced price will be, let's open parenthesis, will be number of shares produced. I say the number of shares produced minus the demand. So means if the whole demand is bought, the number of shares remaining to be sold at reduced price will be number of shares produced minus demand, right? So click enter, we'll have 100. Okay, let's see if it works if we change it the other way around. If the number of shares is lesser than the demand. So if the number of shares, let's say the number of shares is 1,500 and the demand is 1,550. Okay, so now let's see what we have here. Minus 50. So the number of shares sold at reduced price will be minus 50. But minus 50 is not a value. That is where this model is not working. It's not working properly here. So it has to be 0 because we are not going to have any shares to be sold. So how do we make this 0? We still come back here. Okay. We delete this. We use equals to max. Okay. What we are going to use something like a logical test. Now, what it means is we are going to take, normally the equation should be number of shares, which is 1005, minus the demand, which is 1550. But we want to say if the demand is higher than the number of shares produced, let it give us 0 instead of 50. So we put a comma and write 0. But if not, let it give us the right value. So that is what we need to do here. So that is what we have done here. So that's equal to max B10 minus B11. This is the actual equation. But if this demand is lesser than the number of shares, instead of it giving us a negative value here, let it give us 0. That is what it means. So let's hit enter. So when we hit enter, we have this as 1,500. Okay, so we hit enter. Formula text. Now let's check our model. You can see if we have number of shares produced as 1,005 and the demand is higher, which is 1,550, the number of shares sold at full price, you can see because we have used the mean function into these two, the production and the demand, it has picked the model I've learned to pick what? The lower one, because definitely the number of shares that can be sold can never be 1,550. Even if we have the demand, it has to be the number of shares that is produced, because we cannot sell what we did not produce, right? So the model picked the mean of both of them, 1,500 and 500, right? Now, number of shares sold at reduced price. Definitely, if we produce 1,500 and we're having a demand that is higher than the number of shares produced, definitely we will sell all the shares at full price, right? So definitely, number of shares sold at reduced price will be 0. You can see that is why we have 0. The model have been able to pick 0. If not, if we use normal arithmetic, the demand minus the production, we will have minus 50. So it's been able to pick it 0, okay? Because every share to be sold at number of shares sold at full price because the demand is higher than the number of shares. Okay, now let's go into profit. How do we make profit? Now, profit is the same thing as saying revenue minus total cost, right? All right, so first we need to impute what our total cost is. So our total cost we have equals to fixed cost is $600. We click the cell plus our variable cost. Now our variable cost, we have $8 per t-shirt, and we have number of t-shirt produced is 1,005. So the total variable cost will be $8 multiplied by 1,500. So here I have to open brackets. The cost per t-shirt, which is $8, multiplied by the quantity of shirts produced, which is B10, 1,005. I'm going to close parentheses, then I will hit enter. And you can see the total cost is 12,600. I like doing something, as I said, I'm going to use equals to formula text. Okay, for formula text, I like seeing my formula as I go ahead so that I can easily show it to anyone and they will understand what I've done. So close parentheses, hit enter, and that is the formula right there. Now let's impute for total revenue. For total revenue, also we have to start equals with equals to let Excel know that we want to do a calculation or want to impute a formula. All right, now what is our total revenue? Our total revenue definitely is the cost of number of shares sold at full price and number of shares sold at reduced price. Okay, so now let's impute it. So first I'm going to open parentheses. So what is the total number of shares sold at full price? This is 1,005. So I'm going to put that multiplied by what? The price at full price is 12. And we sold 1,500 quantity. So we multiply by $12, which is the price at full price. Then we use plus, we open bracket, then we have to impute also for the number of shares sold at reduced price. Now the number of shares sold at reduced price is 0. So we put that 0 multiplied by the price at reduced price, which is $6. Okay, we close parentheses and hit enter. When we do that, we have 18,000. All right, so I want to also drag this down so that my formula will show. Okay, you can see the formula used there. So now profit is total revenue minus total cost. So I'm going to impute that equals to total revenue minus sign total cost. We hit enter, and that is it. Our total profit is 5,400. Okay, now we have been able to get 5,400. So this can also change. Let's say, for example, now with this profit, let's switch everything to see if our model is working. Now number of shares produced is 1,005, right? Now let's make that more than the demand, because the demand is more than the number of shares produced. Now let's say, for example, we have produced 1,008. Let's see if the model is working properly and the demand. So now the number of shares produced is higher than the demand, and you can see immediately I put it, the number of shares at full price changed to what? 1550. That is, it's taking the number of demanded, which is 1,550, because it has to take the mean of the number of shares produced to demand. You can see it has changed. Now the number of shares sold at reduced price, because if we have a demand of 1,550 and we have sold that, means we still have 250 shares remaining, because 1,008 minus 1,550, 250. The model is doing the calculation on its own. I didn't do anything here, because the model has now recognized changes here and it has impacted in the value here, which is 250, and that is correct. So you can see earlier we have 0, now we have 250. Okay, now you can see it has also updated here, and our new profit is 5,100. The total cost is now 15,000. Total revenue is 20,100, and the total profit is $5,100. So this is how we build the model. So no matter anything we change here, even if we have the same a related kind of business problem, when we don't know the demand and we don't actually know
the number of shares or the number of product that will be buy and the quantity, then definitely we can use this model and we'll get the answer. So it's build one model and use it forever. So this is how you gain this new skill. So please go through it very well, gain this skill and use it in your place of work, and your CEO will thank you for saving them cost, saving them money, and ensuring that they do not lose in this business. So this is a great skill you need to learn if you are working in any business department, especially if you are a business analyst. Bye.